Okay guys, lessons 3.2 and 3.3 are really easy. They're just solving one-step inequalities. So we're going to kind of do this all together. I apologize, it got kind of shrunk up here, but lesson 3.2 is solving inequalities using addition and subtraction. And then lesson 3.3 is solving inequalities using multiplication and division. And then so our objectives would obviously be to use addition, subtraction, multiplication, or division to solve one-step inequalities. Okay, you solve inequalities the exact same way you solve equations. So if I have 3x equals 9, you're going to divide both sides by 3. X equals 3. Okay, if I have 3x is greater than 9, you're going to do the exact same thing. You're going to divide both sides by 3. And then instead of dropping down the equal sign, you just drop down the inequality. There is one small little difference that we'll get to when we multiply or divide by a negative, but we'll get into that. But as you can see, all the same rules for solving one-step equations, they're exactly the same for solving one-step inequalities. So this should be pretty easy. Okay, problem 1, using the addition property. So if our equation, it says what are the solutions of, we have x minus 15 is greater than negative 12. And then graph the solution. So it's the same thing. If you want to make your bridge, just make your bridge down the inequality symbol now. That's all. So if we have x minus 15, we want to add 15 to both sides. And we're going to have x is greater than negative 12 plus 15 is going to be 3. And we won't do this for all of them, but because this graphing thing is still new, let's go ahead and graph this one. So I'll put 0, I'll put 3, and I'll put negative 3. I'm going to put an open circle on 3 because it's just greater than. And then I want the solutions for x is anything greater than 3. So the numbers greater than 3 would be out here, 4, 5, 6. So I'm going to shade out this way, and I'm going to draw an arrow on the end of it because technically that line would go forever. All the numbers greater than 3 are solutions. Okay, and I apologize for this. Problem 2, the main part of this was showing that you can still check your solutions. So first we need to solve this inequality here. 10 is greater than or equal to x minus 3. So if we solve this, what we need to do is add 3 to both sides. So we have 13 is greater than or equal to x. And again, I like to rewrite them, so I would probably rewrite this as if 13 is greater than x, that means x is less than or equal to 13. And what it means by checking your solutions is pick any number you want that's greater than 13. So let's say we pick 20. Okay, so if we want to pick 20 and we want to substitute that back in, let's do 10, and we're just checking this. Is it greater than or equal to 20 minus 3? So is 10 greater than or equal to 17? Yes. So just like with equations, you could plug your number back in to see if you got the same exact thing on both sides to see if it was true. You can still do that with inequalities. You're just going to plug something back in. And because this was greater than or equal to, we could have actually plugged in 13, because if it's, wait a minute. Oh, wait. We did that whole thing wrong. I apologize. This said x was less than or equal to 13, so we can't use 20. We want to use something like, let's say, 10. Okay, so what? I know if this was in class, you would have stopped me. Okay, go back. So let's see. If we're checking 10, then we have 10 is greater than or equal to 10 minus 3, because I put this 10 in for x. So is 10 greater than or equal to 7? Now we have something that's true. Okay, so when I thought about this, I was thinking because x is greater than or equal to 13, we technically could plug in 13, and then 13 minus 3, we would have 10 is greater than or equal to 10. Now, 10 isn't greater than 10, but 10 is equal to 10, so that would be true. I apologize if you wrote down that one with the 20. Just exit out. I apologize. That was wrong. Okay, problem 3. So now we have one, we're going to have to use the subtraction property. So our inequality is t plus 6 is greater than negative 4. So here's our bridge. We want to isolate the variable t, so if we have t plus 6, we want to subtract 6 from both sides, so we have t is greater than, starting with negative 4, subtracting 6, we have t is greater than negative 10. So let's just graph this one. We have 0, we have 10, we have negative 10. Open circle on negative 10 because it's just greater than, and then the numbers that are greater than negative 10 are all these numbers going up this way. Okay? Okay, we have one word problem here. So it says a hard drive on your computer has a capacity of 120 gigabytes. You have used 85 gigabytes. You want to save some home videos to your hard drive. What are the possible sizes of home videos you can save? So because this is an inequality, there's a whole bunch of different sizes you can use. So we want, what are all the possible sizes of home videos you can use? Okay, well, we've already used, let's say, let's pick a variable. What are the possible sizes? So I'm just, instead of using S, because I don't like to use S, I'm just going to use X, and that's going to represent possible sizes, so I don't have to use a variable S. So we've already used 85 gigabytes, plus whatever our possible sizes are. Okay, now, then what I do is the other side's got to be 120. Now you have to figure out, is it going to be less than or greater than? Well, if 120 is the max, this side over here has to be greater than this side. This has to be lower, or I could say less. Okay, if 120 is the most you could have, we need to make our inequality 85 plus x has to be, that side has to be less than, and it could be less than or equal to, because we could use exactly 120 gigabytes. Okay, so you kind of set up your two sides first, and then you have to decide, is this the maximum value or the minimum value? That's going to help you decide if you put the inequality or if you put the less than or the greater than. Okay, subtract 85 from both sides, and we have x is less than or equal to 35 gigabytes. Okay, so anything that's less than 35 gigabytes, those are the possible sizes for home videos. Anything bigger than that isn't going to fit on the hard drive anymore. Okay, so that was it for 3.2. Now we're on 3.3. If you're keeping along in your book, it starts on page 178. So like I told you before, you solve them the exact same way, except if you multiply or divide by a negative, you have to reverse the inequality symbol. And I would pause this or whatever and write that down and star it, underline it, because this is the biggest thing that people forget. So let me show you a couple different examples before we actually get into the examples in the book. So if we have negative 3x is less than 9, you're going to divide both sides by minus 3. Okay, when you do that, if it was less than, you have to flip it to greater than, because now your number, instead of your number being a positive 9, a positive divided by a negative is going to become a negative. And just to make sure your inequality is going the right way, you have to flip the sign. I mean, if you really want to, there's a, on page 179, there's one of those, here's why it works section. And you can go through and you can read that. And if you wanted to, you know, you could come see me and we could talk about that. But it's really not all that important. The important part is that you just flip the sign. So if I have negative 4x is greater than or equal to negative 12. I'm going to divide both sides by negative 4, and the negatives will cancel out, and I have x. You got to flip the sign. It was greater than, now it's less than, and then I have 3. Now, the one thing that gets everybody when they do these is if they have, let's say it was 3x is greater than negative 15. Now, what you're doing is dividing both sides by 3. I know over here on the right side, you're taking a negative number divided by 3, but in that case, you don't flip the sign. It's only what you divide on both sides is a negative or a positive. That's when you flip the sign. So this one is going to stay, whoops, sorry. this one is going to stay x is greater than -5. So don't think every time you see a negative number you have to flip the sign. It's only when what you do to both sides is a negative. And if I can squeeze this in here, if we have x over -2 is greater than 8, if I have to multiply both sides by -2, you're also going to flip the sign. So this is going to become x is less than, I flip the sign, -16. Okay, so just remember, it doesn't necessarily have to do with there being a negative. It's if what you do to both sides is negative. That's when you have to reverse the sign. Okay, so here's the first one. What are the solutions? So let's see. We have x divided by 3 is less than -2. So here's one where people are like, okay, I see a negative, I have to flip the sign. But what you're doing to both sides to undo the division is multiplying by 3, which is positive. So you just multiply by 3, leave the sign alone, and you get x is less than -6. If we have, what are the solutions of -3/4w greater than or equal to 3? Alright, now people get confused. I'm not sure if this is how it was written in the book. Probably in the book it was written like -3/4w greater than or equal to 3, where the negative is like right in line with the fraction bar. It's not on the 3, it's not on the 4, because technically it doesn't matter what it's on. So when I rewrite the problem to do the work, I usually just put it on the top number because it really doesn't matter. Okay, so to undo, anytime I see a fraction, I'm going to try and undo the bottom. So what I'm going to do first is multiply both sides by 4. Now, this negative right here is going with the 3. So we haven't done anything with the negative yet, so we don't have to flip the sign. So I have -3w is greater than or equal to, and 3 times 4 is 12. Now I'm going to divide both sides by -3. The negatives will cancel out. I have w, I have to flip the sign because I divided by a negative, and I get -4. If you would have had the negative on the 4, so if I move this down here and put the negative on the 4, and say, so in that case I would have had to multiply both sides by -4. So I would have had 3w. Because I multiplied by -4, I have to flip the sign around, equals -12. And now when I divide both sides by 3, I don't have to flip the sign. So either way, you get w is less than or equal to -4. I always just put the negative on the top number, but you don't have to put it on both. It's either one or the other. Okay, here we have a word problem. It says, you walk dogs in your neighborhood after school. You earn $4.50 per dog. How many dogs do you need to walk to earn at least $75? So, how many dogs do you need to walk? Let's make D equals dogs. Okay, you earn $4.50 per dog. And your goal is to earn at least $75. Okay, when you see this at least, is that the maximum you want to earn, or is that the minimum you want to earn? If you want to earn at least $75, think of amounts that would be appropriate. At least 75. So that means would be 75, 76, 77, 78. So 75 here is the minimum. Okay, so if that's the minimum, you want this side, the 450 times dog, to be greater than or equal to 75, because that's going to be your minimum. So you want this side over here to be bigger. And then if we divide both sides by 450, you get D equals, when I put this in my calculator, I got 16.66666 repeating, so that's 16 2/3 dogs. Oops, actually I don't want to put this equals. You want to make this greater than or equal to 16 2/3 dogs. And because you can't walk 2/3 of a dog, if it has to be greater than 16 2/3, how many dogs do you need to walk to earn at least $75? It's going to have to be 17 dogs. Okay, we're not rounding up because it was 0.6666. We're rounding up because of the word problem. We need to walk at least, if it's at least, 16 2/3, then it's going to have to be at least 17 dogs until you make that $75. And the last one, real easy, dividing by a negative number. So negative 9y is less than or equal to 63. If we're going to divide both sides by negative 9, if you multiply or divide by a negative, you have to flip the sign around, and we get negative 7. Okay, and that is it.